Let's take a look at number 19 and number 29 from 2.3. Both of these ask you to evaluate a limit that can't be done with direct substitution. So we get to do some algebra first until we can use direct substitution. On 19, the big thing is this 1 plus h to the fourth. So let's work on simplifying that. First of all, I'm going to do that off to the side, kind of as a separate problem. I don't like that pencil. Let's use this one. Okay, 1 plus h to the fourth, which means, of course, multiplying out 4 copies of 1 plus h altogether. And I like to do these two at a time, so let's do these two. And you can either use the box or you can use the FOIL acronym, first, outer, inner, last, but one way or another you need to multiply 1 by 1, h by 1, h by 1 again, so you actually get 2h, and then h squared. That's what the first two would produce. It's also what the last two would produce. So again, 1 plus 2h plus h squared. Okay, now we get to multiply these together. And there's a lot to keep track of there, so rather than trying to do it in my head, I will go ahead and just use the box here. And see, I've got 1, I've got 2h, and I've got h squared, and I've actually got that again. And let's just multiply. Oof. Pretend those are straight lines. Multiply all of the bits together, so there's 1, 2h, and h squared. So that's multiplying 1 by each of these things, multiplying 2h by each of these things gives you 2h, 4h squared, and 2h cubed. And here we get h squared, 2h cubed, and h to the fourth. So we've got 9 terms, and we just need to combine like terms, which for this particular box tend to reside on the diagonals. So the constant is 1. I also have 2h and 2h, so I've got 4 h's in total. I've got h squared, and 4h squared for a total of 6 h squareds. I've got 4h cubes and 1 h to the fourth. If you happen to know the binomial expansion, you can write down this without doing the box at all. But assuming you don't know that, let's just go back to the original problem now and say we have all of this and then minus 1. So 1 plus 4h plus 6h squared plus 4h cubed plus h to the fourth minus 1 all over h. And of course now we are smiling because what happens, what we were hoping would happen did happen, and that something cancels. It's not much, but there's a 1 on the top and a subtract 1, so those can cancel. And the beauty of what's left over is everything on the top now has an h, which means I can factor an h out of the top, and that's what I really wanted to happen, is to be able to factor an h out of the top so I could cancel it with that h on the bottom. So I'm going to go ahead and do that. Let's say h times 4 plus 6h plus 4h squared plus h cubed. Still all over an h. Now there's a factor of h top and bottom that can cancel. And I'm left with, and let's not forget that this is still a limit as h approaches 0. So now I'm left with something that I can do direct substitution on. Once this h on the bottom disappears, there's no domain problem, and I can just substitute 0 everywhere I see an h, which knocks out 3 of these terms and leaves me with just 4. So that is the ultimate limit. As this function, as you plug in numbers that get closer and closer to 0, the outputs will get closer and closer to 4. All right, that is number 19. Let's take a look at number 29 as well. You have two fractions subtracted, which immediately makes me think about common denominator. So that's going to be the first step, and I will actually just squeeze it in here and say both denominators already have a factor of t, so let's get on the right layer. So if you get another factor in here of 1 plus t under the square root, multiply that on the top and bottom of the second fraction, we will have a common denominator. So as we combine these now, the common denominator is t squared root of 1 plus t, and on the top I've got 1 minus this product. Oops, didn't mean to cross that out. And this product is 1 times something. So 1 times something is always just that thing. So 1 minus square root of 1 plus t. And unfortunately, I still can't use direct substitution here. If I put 0 in for t, I'll get 0 times something else, which gives me 0 on the bottom. Does not work. So we already did common denominator. Now we need to do conjugate. So multiply the top and bottom of this fraction by the conjugate. And when I first did this problem, I didn't necessarily know how that was going to help, but it was the only thing I could see to do at this point. So anytime you see two terms on the top or the bottom of a fraction and one of them's a square root, it's worth trying the conjugate to see where that might take you. And after you've done a couple of these conjugates, hoping that something's going to cancel, you should learn pretty soon that we do need to multiply out the conjugate pair. So the 1 minus and the 1 plus, that pair. But we typically don't want to multiply out the other part. It creates a big mess that we then just have to factor. So why not leave it in factored form? So on the top, first, outer, inner, last, or box, 1 times 1 is 1. The inner and the outer part of the multiplication always cancel. That's how conjugates work. So notice we get a negative square root of 1 plus t times 1 and a positive square root of 1 plus t times 1. Those two cancel. The last thing we get is a negative times a positive, so it'll be negative square root of 1 plus t times square root of 1 plus t. The square root of anything times itself removes the square root, and you just end up with 1 plus t. I'm not even going to write the bottom out yet because I want to simplify. So make sure you distribute this minus sign. So you get 1 minus 1. Those cancel. And the top just becomes minus t. And that makes me happy because on the bottom I've got several things all multiplied together, one of which is t. So I know a t can cancel top and bottom. The rest of the stuff is a square root of 1 plus t and 1 plus the square root of 1 plus t. Okay, so cancellation, top and bottom, that t and that t. This does leave a negative 1 on the top. Square root of 1 plus t times 1 plus square root of 1 plus t. This is still a limit as h approaches 0. No, t. Sorry, I don't know why I wrote h there. T approaches 0. So let's still get the limit as t approaches 0, and this is the point where I can use direct substitution. There's a t here and a t there, but I can put 0 in for both of those and just get negative 1 over square root of 1 plus 0 times 1 plus square root of 1 plus 0. So this becomes the square root of 1, which is 1. So I get negative 1 over 1 times 2. 1 plus 1. So this ultimately becomes negative 1/2. So that's our limit for number 29. So both these problems, the hard part is not the limit, the hard part is the algebra. But hopefully that gives you enough to get you going on those two problems.